Hello everyone, welcome back to our channel gsipucmysuru. Today is the last session of our 5th chapter, that is operational amplifier. In today's session, we will be discussing about op-amp as an integrator circuit and op-amp as an active filters. Before that, let us solve one last problem from this chapter. So let's get started. This is the problem what is given. You have to find the output voltage for the following circuit. So this is the circuit. It contains two op-amp circuits. Let me call this as A1 and A2. First, you have to identify which op-amp this circuit is. So A1 is a inverting operational amplifier. Okay? Because the input voltage Vi, which is equal to 3 volts, that is being applied to inverting terminal of the op-amp. So, hagagi idu inverting op-amp. Hotane? So this is an inverting operational amplifier. Coming to this A2, here RF is not given, RF is shorted. Hagagi idu enta amplifier? This is a voltage follower. This is a voltage follower. So we have to find the output voltage V0 of this circuit. Here the output of first op-amp, that is A1, is connected as input to the non-inverting terminal of the op-amp. So let us call the output of this first op-amp as V01 and the final output as V0. So the first op-amp is an inverting op-amp. Hagagi the output voltage, which is equal to V01, will be given by minus RF by R1 of V1, which is nothing but V1 or Vi antane tagona. So minus RF anta helidre 10k, Ri is also equal to 10k. So minus 10 into 10 to the power of 3 divided by 10 into 10 to the power of 3 of Vi value is equal to 3 volts. This entire thing gets cancelled, so I will be left with minus 3 volts. V01 value is equal to minus 3 volts, and that V01 is applied as input for the non-inverting terminal of the second op-amp, that is equal to A2. A2 is a voltage follower ಆಗಿರೋದ್ರಿಂದ ಕಣ್ಣು ಮುಚ್ಕೊಂಡು ಬರಿಬಹುದು. V0 is equal to V01 is equal to minus 3 volts itself. Yake minus? Because the previous input what I am applying is negative, because this is a inverting op-amp. So ಆ minus symbol na ನಾನು retain ಮಾಡ್ಕೊಳ್ಳೇಬೇಕಾಗುತ್ತೆ. ಇಲ್ಲಿ ಏನಾದ್ರು ಪಾಸಿಟಿವ್ ಆನ್ಸರ್ ಅಂತ ಏನಾದ್ರು ಇದ್ದಿದ್ರೆ ನನಗೆ ಇದು ಕೂಡ ಪಾಸಿಟಿವ್ ಅಂತ ಆಗ್ತಾ ಇದೆ. ಸೊ V0, the final output voltage V0 is equal to minus 3 volts. So this is the final answer. Problems are simple, right? Now we'll move on to the next topic, that is op-amp as an integrator. So op-amp as an integrator. What is this op-amp as an integrator? A circuit in which the output is proportional to the integral of the input signal is called as a integrator. So here we are having a circuit in which Vi is connected to the inverting terminal of the op-amp through the resistor Ri. In place of a feedback resistor, we have connected a capacitor whose capacitance is equal to C, and the non-inverting terminal of the op-amp is shorted. V0 is nothing but the output voltage. So let us consider an ideal op-amp. For an ideal op-amp, as usual, open loop gain is equal to infinity and the input impedance Zi is equal to infinity. Zi infinity ಆಗಿರೋದ್ರಿಂದ the current which is entering to the operational amplifier, that will be equal to 0. So IB is the current which is trying to enter the operational amplifier. So IB will be equal to 0. Let us call this as point A and this as point B. Now as usual, applying KCL. Applying KCL to point A. KCL anta helidre the algebraic sum of the currents entering the node is equal to sum of the currents leaving that node. So in this particular node, that is A, the current which is entering is just II, and the current which are leaving is IB as well as IF. So II is equal to IB plus IF. But since the input impedance value is equal to infinity, IB is equal to 0. II is equal to IF. Now let us try to write the formula for current in terms of voltage and resistor. II is nothing but the current which is flowing through the resistor Ri, and between the terminals this and this. So Vi minus Va divided by Ri is equal to, If is nothing but the current which is flowing through the capacitor C. This IF is helping to charge the capacitor. So ಅದನ್ನ ನಾವು ಏನು ಹೇಳ್ತೀವಿ, dq by dt ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆನಾ? Now from the virtual ground concept, VA will be equal to VB. VA will be equal to VB since the potential at the terminal B is equal to 0. ಯಾಕೆ? ಅದು ಗ್ರೌಂಡ್ ಆಗಿರೋದ್ರಿಂದ the potential at the terminal A will also be equal to 0. So let us eliminate this VA from here. So I will be left with VI divided by RI, which is equal to dq by dt. But we are having this formula, Q is equal to C into V. So d of C into V divided by dt. Here C is nothing but the capacitance, C into V ಅಂತ ಹೇಳಿದ್ರೆ the potential drop across the capacitance, that is VA minus V0. VA minus V0 divided by dt. But VA is equal to 0, so that will be eliminated. So C into minus symbol ಬರ್ಕೊಳ್ಳಿ, minus ಇಲ್ಲಿದೆ ಅಲ್ವಾ, minus of C into dV naught divided by dt. So VI by RI is equal to minus C into dV naught by dt. Now integrating on both the sides, we get integral of VI divided by RI and integrating on both sides with respect to t. So VI divided by RI into dt will be equal to, minus C is nothing but the constant value that I am going to take it out, minus C integral of d by dt of V naught ಅಂತ ಬರುತ್ತೆ. But integral ಮತ್ತು differentiator ಎರಡು ಒಟ್ಟಿಗೆ ಇದ್ರೆ that gets cancelled. So I will be left with, let me rearrange here itself, V naught is equal to, this Ri is nothing but constant, Vi is nothing but the input voltage which is a function of time. Time ಮೇಲೆ ಇದು ಡಿಪೆಂಡ್ ಆಗ್ತದೆ. ಸೊ ವಿ ಐ ಇಸ್ ನಾಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ over here. ಸೊ ಆರ್ ಎಫ್ ಮಾತ್ರ ಕಾನ್ಸ್ಟೆಂಟು ಮತ್ತು ಸಿ ಕಾನ್ಸ್ಟೆಂಟ್, minus 1 divided by ಸಿ ಆರ್ ಐ ಆಫ್ integral vi into dt. Since vi is a function of t, I cannot take it out. So this is the final expression where the output voltage is the integral of, or the output voltage is proportional to the integral of input voltage. So this is how we are going to derive the expression for the output voltage of a op-amp as an integrator. Now let's move on to the next topic, that is op-amp as active filters. So what is active filters? Before that, let us try to understand what actually is filters. Filters antandrenu? Filters is nothing but to remove some unwanted things. Hodalva? So here in the electronics, filters are nothing but removing some unwanted signals of different frequencies. Say for example, not all of the electronic devices can be designed to receive the signals of all frequency ranges. Say for example, ನಮ್ಮ ಮೊಬೈಲ್ ಫೋನ್ cannot be used as a walkie talkie because walkie talkie the frequency ನೇ ಬೇರೆ ಇರುತ್ತೆ. ಅದೇ ಮೊಬೈಲ್ ಫೋನ್ cannot receive the radar signal because radar signal frequency ನೇ ಬೇರೆ ಇರುತ್ತೆ. So for different applications of the signals, the frequencies are also different. We are going to design a device, or we are going to design a circuit such a way that it will be able to receive only few range of frequencies eliminating or leaving some other range of frequencies. So what is this active filters? Active filters are nothing but a circuit which uses the active components. Active components ಅಂದ್ರೆ ಏನು ಅಂತ ನಾವು ಫಸ್ಟ್ ಇಯರ್ ನಲ್ಲಿ ನೋಡಿದ್ವಿ. ಆಕ್ಟಿವ್ ಕಾಂಪೊನೆಂಟ್ಸ್ ನಲ್ಲಿ ನನಗೆ ಆಪ್ ಆಂಪ್, ಟ್ರಾನ್ಸಿಸ್ಟರ್ಸ್, ಡಯೋಡ್ಸ್ ಅಂತೆಲ್ಲ ಬರುತ್ತೆ. ಅದೇ ಪ್ಯಾಸಿವ್ ಕಾಂಪೊನೆಂಟ್ಸ್ ಅಂತಂದ್ರೆ ರೆಸಿಸ್ಟರ್ಸ್, ಕೆಪಾಸಿಟರ್ಸ್ ಅಂಡ್ ಇಂಡಕ್ಟರ್ಸ್. ಸೊ ಆನ್ ಅ whole, what is this active filters? The filters which uses the passive components like resistors, capacitors along with some of the active components like op amp is called as a active filters. So ಈ active filters ನಲ್ಲಿ there are two types. One is low pass active filter, the other one is high pass active filters. Let us try to understand them separately. So the first one is active low pass filter. So what is this active low pass filter? Active low pass filter are nothing but the circuit which provides the output from the frequency 0 to some range, what is called as the FC. It is called as the cutoff frequency. So 0 in the frequency range ನಾನು ಮಾತಾಡ್ತಾ ಇದ್ದೆ. This is the frequency scale. So 0 in the the point, let me call that as FC, and that is nothing but the cutoff frequency. 0 ಇಂದ ಈ cutoff frequency ಒಳಗಡೆ ಯಾವ ಸಿಗ್ನಲ್ಸ್ ಬರುತ್ತೋ ಅದನ್ನ ಮಾತ್ರ ಔಟ್ಪುಟ್ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ. ಇಲ್ಲಿಂದ ಮುಂದಕ್ಕೆ ಬರುವಂಥ ಸಿಗ್ನಲ್ಸ್ನ ಎಲಿಮಿನೇಟ್ ಮಾಡುತ್ತೆ. ಸೊ ಇಟ್ ಬ್ಲಾಕ್ಸ್ ದ ಸಿಗ್ನಲ್ಸ್ ವಿಚ್ ಆರ್ ಅರೈವಿಂಗ್ ಆಫ್ಟರ್ ದ ಕಟ್ ಆಫ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ಇಟ್ ಈಸ್ ಬ್ಲಾಕಿಂಗ್ ದ ಸಿಗ್ನಲ್ಸ್. ಈ ಕಟ್ ಆಫ್ ಫ್ರೀಕ್ವೆನ್ಸಿಯಿಂದ ಒಳಗಡೆ ಬರುವಂಥ ಫ್ರೀಕ್ವೆನ್ಸಿ ಸಿಗ್ನಲ್ಸ್ನ ಮಾತ್ರ ಅದು ಅಲೌ ಮಾಡುತ್ತೆ. ಸೊ ಹಿಯರ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್ ದಿಸ್ ಸರ್ಕ್ಯೂಟ್, ಆ್ಯಂಡ್ ದಿಸ್ ಸರ್ಕ್ಯೂಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಅಸ್ ಅ ಫಸ್ಟ್ ಆರ್ಡರ್ ಆಕ್ಟಿವ್ ಲೋ ಪಾಸ್ ಫಿಲ್ಟರ್. ಇದನ್ನು ನಾವು ಫಸ್ಟ್ ಆರ್ಡರ್ ಆಕ್ಟಿವ್ ಲೋ ಪಾಸ್ ಫಿಲ್ಟರ್ ಅಂತ ಕರಿತೀವಿ. ವೈ ದ ನೇಮ್ ಫಸ್ಟ್ ಆರ್ಡರ್ ಆಕ್ಟಿವ್ ಲೋ ಪಾಸ್ ಫಿಲ್ಟರ್ ಅಂತ ಹೇಳಿದ್ರೆ, ಫಾರ್ ದ ಫಿಲ್ಟರ್ ಸರ್ಕ್ಯೂಟ್ ದಿಸ್ ಆರ್ ಅಂಡ್ ಸಿ ಪ್ಲೇಸ್ ಅ ಮೇಜರ್ ರೋಲ್. ಒಂದು ಸೆಟ್ ಆಫ್ ಆರ್ ಅಂಡ್ ಸಿ ಇದ್ರೆ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಅಸ್ ಫಸ್ಟ್ ಆರ್ಡರ್ ಆಕ್ಟಿವ್ ಫಿಲ್ಟರ್ಸ್. ಇದೇ ಆರ್ ಅಂಡ್ ಸಿ ಇದು ಇನ್ನೊಂದು ಕಾಂಬಿನೇಷನ್ ಇದ್ರೆ ಅದನ್ನ ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ಫಿಲ್ಟರ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಅದೇ ಕಾಂಬಿನೇಷನ್ ಮೂರು ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಅದನ್ನ ಥರ್ಡ್ ಆರ್ಡರ್ ಆಕ್ಟಿವ್ ಫಿಲ್ಟರ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಹಿಯರ್ ದ ಇನ್ಪುಟ್ ಸಿಗ್ನಲ್ VI will be applied to the non-inverting terminal of the op amp, and the inverting terminal of the op amp is grounded through the input resistor Ri. RF is nothing but the feedback resistor which is connected between the output and the inverting terminal of the op amp. So the cutoff frequency, ideally ನಾನು ಹೇಳೋದಾದ್ರೆ, if I consider this as the 0th frequency range, ಇದು frequency 0th ಫ್ರೀಕ್ವೆನ್ಸಿಯಿಂದ FC ಬರೋ ತನಕ ಮಾತ್ರ ನನಗೆ ಸಿಗ್ನಲ್ಸ್ನ ಮುಂದಕ್ಕೆ ಹೋಗೋಕ್ಕೆ ಅಲೋ ಮಾಡಬೇಕು. ದ ಸರ್ಕ್ಯೂಟ್ ಮಸ್ಟ್ ಪ್ರೊಡ್ಯೂಸ್ ಎನ್ ಔಟ್ಪುಟ್ ಓನ್ಲಿ ಅಪ್ ಟು ದ ಫ್ರೀಕ್ವೆನ್ಸಿ FC. ಆದರೆ ಪ್ರಾಕ್ಟಿಕಲಿ ನನಗೆ ಆಗಲ್ಲ. ಎಕ್ಸಾಕ್ಟಾಗಿ ಆ ಪಾಯಿಂಟಿಗೆ ಬಂದಾಗ ನನಗೆ ಸಿಗ್ನಲ್ಸು ಆಲ್ ಆಫ್ ಎ ಸಡನ್ ಸ್ಟಾಪ್ ಆಗಲ್ಲ. ಸೊ ಪ್ರಾಕ್ಟಿಕಲಿ ದ ಔಟ್ಪುಟ್ ವಿಲ್ ಬಿ ಲೈಕ್ ದಿಸ್, ಈ ಥರ ರೇಂಜ್ ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ದ ಫ್ರೀಕ್ವೆನ್ಸಿ ರೆಸ್ಪಾನ್ಸ್ ಕರ್ವ್ ಆಫ್ a first order active low pass filter. So this is the frequency range. ಇದನ್ನ ನಾವು AV ಅಂತ ಕರಿತೀವಿ, ಆ್ಯಂಡ್ ಕರೆಕ್ಟಾಗಿ ನಾನು ದಿಸ್ ಇಸ್ AV ಮ್ಯಾಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಆ್ಯಂಡ್ ಈ ಕಟ್ ಆಫ್ ಫ್ರೀಕ್ವೆನ್ಸಿನ ನಾನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, ಆಫ್ಟರ್ ಪ್ಲಾಟಿಂಗ್ ಅ ಗ್ರಾಫ್ ಲೈಕ್ ದಿಸ್ we are going to calculate AV max by √2. ಆ ಪಾಯಿಂಟಿಂದ we are going to draw horizontal line such that it is cutting some point of the graph. ಆ ಗ್ರಾಫ್ ಇಂದ ವರ್ಟಿಕಲ್ ಲೈನ್ ನ ಡ್ರಾಪ್ ಮಾಡಿ we are going to call that as FC. So the formula in order to calculate this cutoff frequency is FC is equal to 1 divided by 2 pi of R1 C1, where R1 value is this and C1 value is this, and the gain formula is AV 1 plus RF divided by RI. ಯಾವ ಫಾರ್ಮುಲಾ ಇದು? ದಿಸ್ ಇಸ್ ಅ ನಾನ್ ಇನ್ವರ್ಟಿಂಗ್ ಆಪರೇಷನಲ್ ಆಂಪ್ಲಿಫೈಯರ್ ದ ವೋಲ್ಟೇಜ್ ಗೇನ್ ಫಾರ್ಮುಲಾ ತಾನೆ. ಸಿನ್ಸ್ ದ ಇನ್ಪುಟ್ ಇಸ್ ಕನೆಕ್ಟೆಡ್ ಟು ದ ನಾನ್ ಇನ್ವರ್ಟಿಂಗ್ ಟರ್ಮಿನಲ್ ಆಫ್ ದ ಆಪ್ ಆಂಪ್, ಈ ಫಾರ್ಮುಲಾನೇ ನಾವು ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತೇವೆ. ಕ್ಲಿಯರ್? ನೌ ಲೆಟ್ಸ್ ಮೂವ್ ಆನ್ ಟು ದ ನೆಕ್ಸ್ಟ್ ಟಾಪಿಕ್, ದಟ್ ಇಸ್ ದ active high pass filter. So this is the circuit what we are going to use in order to understand this active high pass filter. Active high pass anta yake? Because this is a op amp. Along with op amp I am going to use these passive components. So ಯಾವ ಫಿಲ್ಟರ್ ಸರ್ಕ್ಯೂಟ್ ನಲ್ಲಿ ನಾವು ಆಕ್ಟಿವ್ ಕಾಂಪೊನೆಂಟ್ ಅಂದ್ರೆ op amp ನ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತೀವೋ ಆ ಥರ ಫಿಲ್ಟರ್ಸ್ ನ we are going to call it as active filters. So what is this active high pass filter? Before that we saw active low pass filter where R and C places were interchanged. Here R1 was present and here C1 was present. So active high pass filter anta helidre, it is nothing but a circuit which produces the output from the cutoff frequency. ಈ ಕಟ್ ಆಫ್ ಫ್ರೀಕ್ವೆನ್ಸಿಯಿಂದ ಮುಂದಕ್ಕೆ ಸಿಗ್ನಲ್ಸ್ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ. ಐ ಮೀನ್ ಅಲ್ಲಿಂದ ಮುಂದಕ್ಕೆ ದ ಸರ್ಕ್ಯೂಟ್ ವಿಲ್ ಪ್ರೊಡ್ಯೂಸ್ ಆನ್ ಔಟ್ಪುಟ್ ಆ್ಯಂಡ್ ದ ಸಿಗ್ನಲ್ಸ್ ವಿಚ್ ಇಸ್ ಲೈಯಿಂಗ್ ಬಿಲೋ ದ ಕಟ್ ಆಫ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ವಿಲ್ ಬಿ ಬ್ಲಾಕ್ಡ್ ಕಂಪ್ಲೀಟ್ಲಿ. ಸೊ active high pass filter, even this is a first order active high pass filter because I am using only one set of R1 and C1. ಅದೇ ಈ ಥರದ್ದು ಇನ್ನೊಂದು ಸೆಟ್ಟನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡ್ರೆ then that circuit will be called as a second order active high pass filter. So frequency response curve-ನ ಬರಿಬೇಕಾದ್ರೆ we are going to get the graph like this. ಈ ಥರ ಗ್ರಾಫ್ ಸಿಗುತ್ತೆ. The maximum value will be called as AV max, that is nothing but the maximum gain of this particular circuit. So FC na calculate ಮಾಡಬೇಕು ಅಂದರೆ AV max by root 2 and from that point I am going to draw a vertical line which I am going to mark it as FC, that is nothing but the cutoff frequency. ಈ cutoff frequency ಇಂದ ಮುಂದಕ್ಕೆ higher frequency from the cutoff frequency will be allowed to pass through and the signals which is lying below the cutoff frequency will be blocked. ಅದಕ್ಕೋಸ್ಕರ high pass filter. And if I want to calculate that FC, the formula is same. FC is equal to 1 divided by 2 pi R1 C1 and the voltage gain formula is also same. AV is equal to 1 plus RF divided by Ri. So this is all about the active high pass filters. So active filters ಅಂತಂದ್ರೆ ಏನು? The circuit which makes use of the passive components like resistors and capacitors along with some of the active components like op amp is called as the active filters. Now let's move on to the last topic of this chapter, that is comparators. Till now we saw the negative feedback applications of an op amp, that is inverting op amp, non-inverting op amp, summing amplifier or adder, op amp as a differentiator. ಈ ಥರ ಎಲ್ಲದರಲ್ಲೂ ಕೂಡ we had taken a feedback, that is we had connected a portion of the output back to the inverting terminal of the input through the resistor RF. So ಹಾಗಾಗಿ ಅದನ್ನು negative feedback, since that RF was connected between V0 and the inverting terminal ಆಗಿರೋದ್ರಿಂದ ಅದನ್ನು negative feedback ಅಂತ ಕರಿತಾ ಇದ್ವಿ. So all those were the applications of the negative feedback circuit. This comparator is an example of a open loop circuit. So in this open loop circuit, the output will not be connected back to the inverting or the non-inverting terminal of the op amp. So comparator, the name itself is specifying, it compares between the two signals. So it produces the output voltage depending upon the difference between the two input signals what I am applying to inverting and non-inverting terminal of the op amp. So V0 is equal to gain into V2 minus V1, A into V2 minus V1. So in this open loop gain of a operational amplifier will be equal to infinity anta na characteristics alle helide, but practically that will not be possible. Practically the open loop gain of an amplifier is equal to 10 to the power of 5. But even if the difference between these two input signals is few millivolts, the difference ಬರೀ ಸ್ವಲ್ಪವಾಗಿದ್ರೂ ಕೂಡ that will be multiplied with this gain and the output will be hundreds of volts. Output hundreds of volts ಬರುತ್ತೆ, but that is practically not possible to build a such circuit. So what we are going to do is, this circuit, this comparator will try to swing or will try to produce the output voltage between plus V saturation and minus V saturation depending upon which of the input signal is higher. ಯಾವ input signal higher ಇದೆ ಅದಕ್ಕೆ ತಕ್ಕಂಗೆ ನನಗೆ output will be trying to swing from plus V saturation to the minus V saturation, where plus V saturation is equal to plus VCC what we are going to connect, and minus V saturation is nothing but equal to minus VCC. I mean to say, if I am going to connect the VCC to plus 12 volts, plus V saturation will be equal to plus 12 volts, minus VCC na ನಾನು ಅಥವಾ minus VE na minus 12 volts ಕೊಟ್ಟರೆ minus V saturation will be equal to minus 12 volts. Let us try to understand this. If V1 is greater than V2, then the output voltage V0 is equal to minus VEE, which is called as minus VSAT. Or if V1 is less than V2, then the output voltage is equal to plus VCC, which will be called as plus VSAT. So the output will be swinging from plus V saturation to minus V saturation. And then ನನಗೆ output waveform ಈ ಥರ ಬರುತ್ತೆ. Plus V saturation ಇಂದ minus V saturation ಈ ಥರ swing ಆಗುತ್ತೆ. So this is plus VSAT and this is minus VSAT. So the output will be swinging from plus V saturation to minus V saturation depending upon which of the input voltage is greater. So this is all about the comparator. Now let's move on to the last topic of this chapter, that is the zero crossing detector. This zero crossing detector is one of the application of a comparator circuit. Zero crossing detector circuit nalli the input signal will be applied to the non-inverting input terminal of the op-amp, and the output signal will entirely depend upon the input signal whether it is crossing a zeroth line or not. If the input signal what I am going to apply is like this, the output of this signal will be a square waveform. If I consider this as the input signal, this as the input signal Vi with respect to t, and this is equal to 0. Now the output voltage V0 will be equal to plus V saturation if Vi is greater than 0, and V0 will be equal to minus V saturation if Vi is less than 0. So this is the Vi waveform, that is the input voltage waveform. So these are the portions in which the input waveform or the input voltage is greater than 0. So ಹಾಗಾಗಿ ನನಗೆ output voltage V0 will be equal to plus V saturation. Let us mark this plus V saturation and minus V saturation. ಅದೇ ಥರ ಇಲ್ಲಿ ಕೂಡ ಮಾರ್ಕ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. So this is the point in which the input signal is greater than 0. So ಆ ಪಾಯಿಂಟ್ ಇಂದ ಈ ಪಾಯಿಂಟ್ ತನಕ, ಯಾಕಂದರೆ ಈ ಪಾಯಿಂಟ್ ಇಂದ Vi is decreasing, so Vi is crossing the 0 line, Vi is less than 0. So ಇಲ್ಲಿ ತನಕ ನನಗೆ ಏನಾಗುತ್ತೆ plus V saturation. So next if Vn is less than 0, then output voltage will be minus VSAT. ಅದೇ ಥರ ನನಗೆ ಈ ಥರ waveform ಬರುತ್ತೆ. So this zero crossing detector can be called as a circuit which produces a square waveform anta karibodu, because when Vin is greater than 0, the output voltage will be equal to plus V saturation, and if Vin is less than 0, then the output voltage will be equal to minus V saturation. So this is all about the zero crossing detector, which is one of the application of a comparator circuit. Clear? Now it's time to have a look on part 2 of this session. Hello everyone, welcome back to the part 2 of this session. In this session we are going to see the other packages of op-amp, that is TDA 2003A car audio power amplifiers. Even the car must have some amplifiers, and the amplifiers which are present in the car is TDA 2003A car audio power amplifiers. So this TDA 2003A is from ST Microelectronics, is a high performance audio amplifier designed for only car radios. This 10 watt amplifier will deliver an output current of 3.5 amps and uses a power supply of up to 18 volts DC. The 5-pin pentawatt package offers savings in space and cost, requiring only a few external components. It is a 5-pin amplifier IC. The pin 5 and 3 are used to power the amplifier IC, and the audio signal will be applied through pin number 1, which is a non-inverting input, and the amplified audio output can be obtained through pin number 4, as it is already shown in the picture. It contains 5 different pins, and the different pins are already named in the picture. Other package of op-amp, that is metal can package op-amp. This is nothing but a general purpose op-amp itself, that is the 741 IC itself, but that 741 IC is available in the form of a metal can. which is available these days in several different versions and in a variety of package designs, including 8-pin DIL package, which we have already discussed in the earlier sessions. So this is an 8-lead T05 8 package. The T05 is a through-hole device enclosed in a metal can with 8 leads, or it's also called as terminals. In some cases, the metal can is isolated from the terminals and used to attach a heat sink. It contains 8 different pins, and those 8 different pins will be named as usual as we have seen in the DIL package. IC nalli nodidvalla adhe thara naming idrallu kuda irutte. And applications anta bandaga 741 IC ಏನು application ಇದೆಯೋ ಅದೇ application, because this is also the 741 op amp itself, but it is available with a different design ashte. So this is the internal structure of a metal can op amp. So 8 pins ಇದೆ. For all those 8 pins, the central nalli iruvantaddu, that is nothing but a circuit which is connected to 7 pins only. The one pin ಗೆ ಯಾವುದೇ ರೀತಿ ಕನೆಕ್ಷನ್ ಮಾಡಿಲ್ಲ, ಬಿಕಾಸ್ ಇನ್ 741 IC 1/8 pin will not be used. ಸೊ ಹಾಗಾಗಿ ಇಲ್ಲಿ ನಮಗೆ ಕನೆಕ್ಷನ್ ಕೂಡ ಮಾಡಿಲ್ಲ. With this, I am going to conclude the part 2 of this session. Thank you. I hope you are getting something to learn from the part 2 of every session. If yes, then please do comment in the comment box. With this, let us sign off from this session. In the next session, I'll be coming with a new chapter. Until then, take care. Bye-bye.